Hey everyone, here we have one of the tricky questions from the test, and it has an absolute value along with an inequality sign. So we want to concentrate on the absolute value right now. We know that the absolute value of x minus 4, let's just kind of take a sidebar here, absolute value of x minus 4 always makes the value inside positive. So let's think about a value greater than 4 for x. If x is greater than 4, then if x is greater than or equal to 4, then the result of this is just x minus 4. For instance, if x is 5, we'd get 5 minus 4 within the absolute value, which is 1, and the absolute value of 1 is just 1, so we don't even need the absolute value signs. But if x is something less than or equal to 4, say 3, then we'd get negative 1 inside the absolute values. And we have to make that positive because that's what the absolute value does. It makes a negative number positive. So it does that by multiplying by negative 1. So in other words, we're going to get negative x plus 4 if x is less than or equal to 4. If x is less than or equal to 4. Again, let's think about this. If x is less than or equal to 4, let's say 3, then we want to get an answer of 1 out. Well, this does it because it'd be negative 3 plus 4 equals 1, which is exactly what we want. So we run it once with the positive and just drop the absolute values, and we run it once with the negative, but we have to be clear about when we do that. We run it with the positive if x is greater than 4, and run it with the negative if x is less than 4. So keeping those in mind, I'm going to erase, and we'll again run it twice and see what our answers produce. So I'm going to kind of split this down the middle and say if x is greater than or equal to 4, this is our first sort of criteria, then we can just drop the absolute values and we solve the equation as if it were an equality instead of an inequality. I'm going to combine the x's, so I get negative 4 minus 1 on this side and 2x on this side, just by simple algebra. This is negative 5 is less than or equal to 2x. So negative 5 over 2 is less than or equal to x, or x is greater than or equal to negative 5 over 2. If we think about this solution on a number line, here's negative 5 over 2. We're saying x has to be greater than this, but we're also saying x has to be greater than 4. Right? We said that from the beginning. This is why these criteria are so important. So our actual answer from this side is x is greater than 4. And the reason for that is both of these criteria have to be met. The fact that we said x is only greater than or equal to 4 when we follow this process, and x is greater than or equal to negative 5 over 2. If both of those have to happen, that just means x is greater than 4. So that's that side. Now we look at the other side to get even more of it. This is definitely part of our solution. Now we see if we can add to that solution. So we said if x is less than or equal to 4, we're going to run a negative sign through. So that will produce negative x plus 4 is less than or equal to 3x plus 1. Again, combine, we get 3 is less than or equal to 4x. So 3 over 4 is less than or equal to x, or x is greater than or equal to 3 over 4. If we think about this on the number line, we started with x being less than 4, so this side, that was our first criteria up here. And then we said x is greater than 3 over 4. If we put 3 over 4 on the number line, x being greater than it, that's this way. So the answer to this side is 3 over 4 to 4 is the solution. Combining these two together, since these are both solutions, our final solution is x is greater than 3 over 4. Because this one says 3 over 4 to 4, and this one says 4 to infinity. All of those things are solutions. So we combine those, and this is our total. So we always want to think about why we're running a negative sign through. So we don't just say, oh, we're going to run it once positive, once negative. We have to set up the criteria for which we're going to do that. So hopefully this is helpful. You can always email us with more questions, info@arnoldtutoring.com. Thanks.